Hello students, what is going on? My Abdullah Momin, KMES English Medium High School and Junior College, and this is your lecture number 7 of chapter sound from class 11 physics. And in this video, we are going to study about Newton's formula for velocity of sound and Laplace's correction. So Newton's formula for velocity of sound. So Newton's has suggested that, or Newton's has calculated the velocity of sound, and the calculation is based on a certain assumption. So first we are going to see the assumption on which the velocity of sound has been calculated by Newton. So Newton's assumed that propagation of longitudinal wave was studied by Newton, and sound wave travels through a medium in the form of compression and rarefaction. So what Newton said that sound is a longitudinal wave. So when sound travels in a medium, there is a formation of compression and rarefaction. And we all know that compression is a region where the particles are crowded, hence the density of the medium is greater at compression, while the density is smaller in the rarefaction. Hence the velocity of sound depends on elasticity and density of the medium. And Newton's gives us the formula for calculating the velocity of sound, and it is V is equal to square root of E by rho, where E is the modulus of elasticity of the medium and rho is the density of the medium. Now Newton's assumed that during propagation of sound, there is no change in the average temperature of the medium. And if there is no change in temperature, that means the sound wave propagates in the air is an isothermal process. Isothermal process means the process in which temperature remains constant. And he suggests that isothermal elasticity should be considered. So the volume elasticity of air determined under the isothermal change, and it is called as isothermal bulk modulus, and that is equal to the atmospheric pressure. So modulus of elasticity can be written as atmospheric pressure P. Hence Newton's formula for speed of sound V instead of E, he has suggested that it is a isothermal bulk modulus, and isothermal bulk modulus is equal to P. So now we have the formula V is equal to square root of P by rho, where P is the atmospheric pressure and rho is the density of the medium. Now atmospheric pressure, the formula of atmospheric pressure P is equal to HdG at NTP. NTP means normal temperature pressure. So H is the height of the mercury column, that is 0.676 meter of mercury, and the density of mercury is 13,600 kg per meter cube. Rho is the density of the medium. Since sound is traveling in a medium, that means the density of air, that is 1.293 kg per meter cube, and g is acceleration due to gravity, that is always constant, and its value is 9.8 meter per second. So now instead of p, we will put h dg, and the value of h is 0.76, the value of d is 13,600, and the value of g is 9.8, and rho is 1.293. So V can be written as square root of 0.76 into 13,600 into 9.8 divided by, and when we will calculate this, we will get the value of speed of sound as 279.9 meter per second at normal temperature pressure. So according to Newton, the velocity is 279.9 meter per second, but this is the value of velocity of sound according to Newton's formula, but the experimental value of velocity of sound at 0 degrees Celsius as determined earlier by a number of scientists is 332. The difference between predicted value by Newton's formula, that is 279.9, and the experimental value, that is 332, the difference is very large and it is not due to the experimental error. And the experimental value is 16% greater than the value given by the Newton's formula. So Newton's could not give satisfactory explanation of this discrepancy. It was resolved by the physicist Pierre-Simon Laplace. So now Laplace has made a correction in Newton's formula. So let's see what Laplace said. So according to Laplace's correction, the generation of compression and rarefaction is not a slow process but a rapid process. So Newton said that the formation of compression and rarefaction is slow process, but Laplace suggests that the formation of compression or rarefaction is a very rapid process. That means if the frequency is 256 Hz, the air is compressed and rarefied 256 times in a second. Such process must be a rapid process, and heat produced during the compression and it lost during rarefaction. This heat does not get sufficient time for dissipation, and due to the total heat content remains the same, such process is called as adiabatic process. And hence adiabatic elasticity must be adiabatic and not isothermal elasticity, as was assumed by the Newton. So Newton said that it is isothermal elasticity, but Laplace has made a correction. He said that it is an adiabatic process because heat is constant. So the adiabatic modulus of elasticity of air is given by E is equal to gamma P, where P is the pressure of the medium, that means air, and rho is the ratio of specific heat of air at constant pressure to the specific heat of air at constant volume, called as adiabatic ratio. So this is the formula of gamma, that is Cp upon Cv, and the ratio of Cp upon Cv is 1.41. That means the value of gamma is 1.41. Now Newton's formula for speed of sound in air as modified by Laplace to gives us, so instead of E, he has put it gamma P, and the value of gamma is 1.414. P is HdG, where H is 0.76, D is 13,600, G is 9.8, and rho is 1 point. So after calculating this, we will get the value of velocity of sound as 332.3 meter per second. This value is in close agreement with the experimental value as seen above. So the velocity of sound depends upon the properties of medium. So that's it, student. Thank you very much. I will catch you next time.